So I want to start by explaining each of the different strategies we went through. I want you to notice here, Marcel is not thinking about 84. Um, when we think about the standard algorithm, we think 84 plus 79, we've been accustomed to adding, right, the ones first, right, starting from left to right. But if we look at Marcel's strategy, he's not thinking, and then we think about 4 and 9 and 8 plus 7. Well, that's not how Marcel's thinking about it. He's not seeing 8 plus 7, but he's seeing, right, 80 plus 4 plus 70 plus 9, right? He's seeing this as 150, then plus 13. So he's attending to place value and adding from left to right instead of right to left as we would ones first in the standard algorithm. And I really want us to do this comparing, contrasting, and see how certain methods can help us develop the standard algorithm. If we notice when he's adding, the different digits here, right? 400 plus 300 gives us 700, but then 7D plus 50 gives us 120. So we see there's no regrouping in Marcel's strategy. And that's purposeful because regrouping is a very abstract concept. And so we just want to think first with students, just start with what do we see? And so another way to represent this is called expanded form. And that's what this is called here. When we write numbers out and add the pieces together is called expanded form. So like here, this 634 would be 600 plus 30 plus 4 in expanded form. And so now let's look at the base 10 blocks and see how we can see these ideas that Marcel is presenting. All right. So I want to show Marcel's strategy with the base 10 blocks. So I just made up another example, 147 plus 275, and I pulled down all of the blocks. 100, one flat, 1, 2, 3, 4 rods, and 7 units. Same thing, 2 flats, 7 rods, and 1, 2, 3, 4, 5. Oh, sorry, I have too many. Delete here. And I just found a new tool, right? Duplicate selected objects. So instead of having to drag them all from the top, click here, and then you can just duplicate to get as many as you need. Just saves you a step with using the virtual manipulatives because they're tough. All right, so let's think about Marcel's strategy. He goes left to right, he doesn't start with the ones, right? Like in the standard algorithm. So he sees 1 flat, 100, and 2 flats to get 3 hundreds, 3 flats. We see that right there. 1, 2, 3. Now I'm thinking, okay, move to my tens column, my rods. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or 40 plus 70 is 110, or 11 tens, 11 rods. And now I see 7 ones and 5 ones, right? 7 and 5, and that gives me 12. And so we can see this notion of, right, 110 and 2 ones, or 100 and 110 left over, right, by regrouping. So here we go. Oh, oops, I'm going to turn the pen off, right? We can put 10 rods together. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we have another flat, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that went underneath. 8, 10. Right, stack these up. And now what do I see? I see I have, bring my pen back, right? 4 flats, 1, 2, 3, 4, and 2 rods, and 2 left over, right? 2 ones, 422. So now let's move to Abby's strategy. Here we can see she's thinking about making these friendly numbers, right? She turns 79 into 80 and 47 into 46. One way we can think about this as not just necessarily turning into, I wanted us to be careful that in no way is she rounding. So she's not rounding 79 to 80, because think about then what's happening with 47. 47 doesn't round to 46. What she's doing is she's seeing 79 and saying, hey, I can add 1 to 79 and get 80. And if I add 1 to 79, then I need to take 1 away from 47 to get 46, right? To make sure that my sum doesn't change, because what I can see here is that a positive 1 and a negative 1 sums to 0, right? They don't cancel out. We can think about if we add a positive and then take away that same number as a negative, now we didn't change the total quantity, right? And so this is using the identity properties, sorry. And so that's one way we can explain Abby's strategy, is this idea of using the identity property, right? She adds 1, takes 1 away, so that's summing to 0. We can also think about this, sometimes this is called compensating, right? If we add 1 and we take 1 away. Another way we can think about this is if we write our numbers horizontally, then we can think about 79 plus 47. Well, I can decompose 47 as 1 plus 46. And now when I think about 79 plus 1, right, this is my associative property. I can associate 79 plus 1 and get 80 plus 46. And now I want you to notice what she's doing is making these friendly numbers, right? She's making a 10. So that's important because it just makes, adding a little bit easier. Sorry, that. And now 80 plus 46. And so this way of recording on the right side horizontally is just a way to show how we can decompose 47. So that's just another way to think about this. I don't know that Abby necessarily is, I guess we could think about it that way, right? She takes 1 from 47 here and quote unquote gives it to the 79, right? We can think about here. And if we look at example number 2, I'll use a different color, right? Here, when we look at 57 to 55, well, it's not 57, turns into or rounds to 55, as you might think of 88 and 90. But you can think about, I'm going to take 2 from the 7 and give it to the 88 to make that a friendly number, right? So take those 2, take them out, right? Decompose 57, take 2 out of 57 and add it to, right? So take away 2 and then add 2 to 88 there. So let's take this example here of 62 plus 48, because it can work either way, right? Maybe I want to take these 2 from the 62 and give it to the 48. So I'm going to take away 2 from the 62 and I'm going to add 2 to the 48. So that way this becomes 60 plus 50, right? And so the stacked version doesn't make as much sense to me as if we would do this this horizontal method, because now I can decompose 62 as 60 plus 2 plus 48. And now again, we can see the associative property right here. We can associate those numbers together and get 60 plus 50. So now I want to share Abby's strategy of the 62 plus 48, this idea of compensating or making friendly numbers with the base 10 blocks. And the reason I want to show with the base 10 blocks is just because we have these kind of larger numbers. So I can take my 60, I'm going to duplicate this. 1, 2, 3, 4, 5, 6. Here's my 60. Oh, they're just kind of stuck together. What's going on? All right, and then I'm going to take this 1, 2, 3, 4. 1, 2, 3, 4. And here, do we still have 60 here? 1, 2, 3, 4, 5. Duplicate 6, 1, 2, 3, 4, and then here we go. We get 2 here, and then we'll duplicate again, bring it down 1, 2, 3, 4, 5, 6, 7, 8. So here, right, we talked about taking the 2 from the 62 and giving it to, you know, this add end, this to the 48. So we can see that literally right here. We take from this first add end and we give it down here to the bottom. Boom. And now here we can make this a 10 and we can add the numbers together. So now we want to see Jordan's strategy. We can think of, I think for many, you can see exactly what's happening. And if not, I want to just share, remember, what is this called, right? This is our expanded form. And I don't know why that's not writing nicely for us right now, but not a big deal. So he's breaking the numbers, right? Decomposing the numbers by place value and then adding them together. I'm going to let you practice explaining and sharing that idea. How would we use, or what tool would we use to represent this idea, and how would we see that? All right, now for Jose's strategy. This one we went over in class, but I wanted to reiterate it again in case it wasn't quite making sense to you. And what I want you to see is he's seeing each of the digits almost individually, right? He's seeing as 8 plus 3 is my 11, 6 plus 8 is 14, and 2 plus 4 is 6 here. And then what he notices is that, well, can we have more than 10 in the tens column or more than 10 in the ones column? No. So he's regrouping this one set of 10 over, and then this other set of 10 over, and adding that group of 10 tens that he has in the tens column into the hundreds column, and the 10 ones that he has in this ones column, he's regrouping into the tens column. And so let's see what that looks like with the manipulatives, with the representations. So let's take a look at the second example on Jose's, right? He has 373 plus 189. And now we can see this addition here with the base 10 blocks. I set up 3 hundreds, 3 flats, 7 rods, and 3 ones. And then 1 flat, 8 rods, and 9 ones. And so now, as Jose does, right, whether you start left or right, we don't know which direction Jose goes in, but we can see 3 flats plus 1 flat, 1, 2, 3, 4 flats. And then now we see 7 rods plus 8 rods. And we can count how many rods we have. 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And likewise, 3 units and 9 units gives us the 12. So here we can now start seeing this regrouping idea, right? He sees, I have 10 tens, right? Look at all these tens. I have 15 tens, so I can start regrouping them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go, 10. So we regroup that. And likewise, I'll bring the pen back up here. So this gives us how many flats now? 1, 2, 3, 4, 5 flats. right? So here we have 5, and now we're left with 1, 2, 3, 4, 5 rods, and we still have these 12 ones. So likewise, we can regroup the 12 ones. Let me make sure I'm not in the pen anymore. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we go. Boom. 1, 2, 3, 4, 5, 6 now, right? We think about this regrouping here. Take this one rod, move it over, and I see I have 5 flats, 6 rods, and 2 units, 562. So now let's have a look at Donovan's strategy. We can see that he's, again, not grouping, not regrouping. He's seeing the place values in this expanded form idea, right? 100 plus 90 plus 8, and then we're going to subtract 70 plus 9, right? All of these. And so what we see what Donovan's doing, he's thinking about subtraction as kind of this adding a negative number, right? Both the 70 and the 9 are negative if we think about it like this. So 100, minus no hundreds keeps us with 100, but then we think of 70 plus a negative 90 plus a negative 70 gives us this positive 20. And then, but 8 plus a negative 9, right? Or 8 minus 9, as shown here, that's how we get this negative 1. And so I want you to see how by understanding the relationship, the intimate relationship between, or the inverse relationship, addition and subtraction, right? That's why we can add all these numbers, right? 8 minus 9 is the same as 8 plus a negative 9. And so this gives us 120, but minus 1. And so that's 119. And maybe if we wrote it as 100 plus 20 minus 1, right? Now we could see where that 119 comes from. And so for Donovan's strategy, there's not really a great way to represent these large numbers as both positive and negatives. We saw last week how we can use the 2 color counters. The yellow side is positive, the red side is negative, to show that, but we don't need or probably want to get into 70 negative chips or -3 to do these large numbers. So this one, don't worry so much on creating a representation, but understanding the relationship between addition and subtraction, and that subtraction is just the same thing as adding a negative number. So Donovan is pulling on that idea of adding a negative number, or thinking about subtraction as adding a negative number, and fluently then combining both positives and negatives to find these differences in the problems presented here. This one does have a name. This is called partial sums. I mean, not sums, sorry, partial differences. And Marcel's strategy is called partial sums. So the ones, Jose doesn't have a name, and neither does Jordan. Abby, we can think about as decomposing, as making friendly numbers, or compensating. And then Marcel, this is the same thing that was happening in Donovan's strategy, right? Thinking about it, each place value, and then adding each place value individually. This is called partial sums. So again, not that you have to memorize those names, but I just wanted to, the strategies that do have names, I wanted to share those with you. And so now let's look at Chrissy's strategy. And so for Chrissy, her strategy looks a lot like Abby's, but again, now we're not adding, we're subtracting. And so I want to bring your attention to a couple of things with Chrissy's strategy. Again, there's no rounding. And just like with Abby's strategy, we can consider this as like making the friendly numbers, right? What is going on? Friendly numbers or compensating is another way, because this idea that you're adding, right, using the identity property of adding some and taking away others, that's where we can get this idea of compensating. Or compensation for the noun. But so let's look at, take a closer look at Chrissy's strategy. Before we were thinking about like, oh, I can take, some from the bottom number. In Abby's strategy, when we're adding, I can take some from that bottom number and give it to the top number. Or if we, wrote them horizontally, it was easy to see how we could decompose that second addend in those ways. With this one, it might not be so clear. And with subtraction, it brings in another piece where we're still going to use the identity property. It's just hidden in a way. Because if we look at the minuend and the subtrahend, right, 93 becomes 95, or we can add 2 to get 95. But 58, with addition, we added 2, we had to take away 2. But if you look at subtraction, what's the relationship between 58 and 60? Oh, we added 2 again. And so I want you to think about that for a second. Why in subtraction would we add to both the minuend and the subtrahend? Where in addition, if we added some, we had to also take away some. And likewise, right, 93 again, or, right, gave us plus 2 to 80. Why does that say 93 to 85? Oh, I think that's supposed to be 95. Or I never realized that. Maybe this is supposed to be 83. 83 minus 58, right, would be 85 plus, oh, what happened here? Hold on. Sorry about that. I was going too fast and thinking they were the same strategy. And that actually brings me to my next point. What I want you to notice is in Abby's strategy, they focused on making the top number the friendly number. But here, the subtrahend, the bottom number, is the friendly number. So Chrissy's looking at each subtrahend and saying, okay, how do I make that the 0, right? That the multiple of 10, that the friendly number. So in Chrissy's strategy, she said, well, I got to take 8 away here. And if we notice, and so here, take 1 away. And again, 124 to 123, take 1 away. And so in Chrissy's strategy, when we're subtracting, actually what we do to the top, what we do to the minuend, we do to the subtrahend. Both are the same. And so that's why this 93, take 8 away and gives you 85. So that's what's happening there. What I also want to show is that, let's take a look at why that works algebraically, and then I'm going to connect it to the representation. So let's do, I guess, this 93 minus 58. And so what we're thinking about with this take away 8, actually here, maybe let me make some more space. Right, 93 minus 58. And so with Chrissy's strategy, she's saying, I want to take this 8 away because I want this to be my friendly number, my subtrahend of 50. And then, so if I'm doing that, then she's saying I got to take 8 away from the minuend. And we're going to see why that is in a second. But I also want to show this algebraically. And so this gives us this 85 minus 50, which we now see as 35. But why is it minus and minus? That's the question right now. And I want to show you that because if we think about this, right, this is actually taking away, right, 58 minus 8 to get this 50. It's taking away both the 58 and the negative 8. So this is actually this notion of minusing 58, but adding in this 8. So if we wrote it out, it would be 93 minus 8 minus 58, but then plus 8, right? Because this 8 is taking out it's making this 58 less negative, right? If we think about this positive and negative idea. So, and then right here, right, we can see a -8, a +8. This is, again, is the identity property, right? They sum to 0. So there's a little bit of algebra involved in understanding why this strategy works. And so why this still sums to 0. And it's because when we're taking away, right, this subtrahend, right, we have a negative 81, or subtracting an 81, and then we're subtracting also this -1, right, to make that subtrahend a friendly number. So we're taking away the 81, and then we're taking away that -1, and that's why the subtrahend then becomes 80, right? It became less negative in this case. So now let's see Chrissy's strategy in action. And I'm going to use the number line as a representation. And just because this virtual manipulative doesn't show very large ranges, I just tried to simplify the problem a little bit and think about it as 72 minus 65. I just made up a new problem. So again, we can think about, here's 72, right? Here's my 65. We can think about subtraction as the distance or difference between those numbers. So we can find that on the number line. But again, let's use Chrissy's strategy where she says, well, I want to make the subtrahend a friendly number. And whatever I do to the bottom, the subtrahend, I'm going to do to the minuend. And then I'm going to get this as 60, and 72 minus 5 would be 67, right? And so we can think about, I'm gonna put on the numbers so we can see that. We can think about this distance or difference by counting, right, on the number line, or let's look at now this distance or difference between, if I change the subtrahend to 60, right, and then my minuend becomes 67, and now I see this distance, well, maybe I should get a new color here. This distance then hasn't changed, right? It's still 7. So I can change the minuend and subtrahend all I want. And by moving this from 65 down to 60, 1, 2, 3, 4, 5, right? Simplifying or making this 65 a friendly number, I have now changed the minuend and the subtrahend, but I kept the distance the same. So the difference between, or the distance between these numbers stayed the same. And so that's why this compensation strategy works. You can think about it as we saw in the last, on the slides with the algebra of the identity property, or on the number line as keeping the distance or the difference the same. So now I want to contrast Chrissy's strategy with Abby's strategy, right? Chrissy was compensating with the subtraction. So that's where we saw we were keeping the distance or the difference the same. But now I want to show Abby's strategy of the compensation, but in addition, and it's going to be different now. So it's not that the distance stays the same. So with Abby's strategy, what she does is she thinks about making the friendly numbers. So she would take away 3 here, take away 3 here, and keep that there. And we'd get 60 plus 11, right? So here, I'm going to go to back to here. Oh, 1 second. Let's turn on this. And so we can think about addition in a couple of different ways, right? So we can think about this as, can I type in 14? Done. Oh, no, I want it to go to 14. Never mind. Oops, let me trash that. Here, and I want to turn this on, and we got 5. And so let's go all the way to 14. Right? We can think about adding as now 63 plus 14 takes us to 77, right? Or, you know, I'm sure you probably could do that as 3 plus 4, 6 plus 1, right? This, these two numbers probably don't need this strategy, but I just want to illustrate it with numbers that fit on this number line. But now let's look at, so, right, we want to change. We want another 14. But so what I want you to see is now let's look at 60 plus 11. And that takes me to 71. So we can see this distance or difference didn't stay the same. And so this is, with the compensation strategy, different from what it looked like in subtraction. And so here, oh, and that's because I also messed up, right? In Abby's strategy, what we add to the bottom, or what we subtract from the bottom, we have to add to the top. So it is not 63. We take this away, well, we got to add it. So it would be 60 plus 17. And so there we go. That makes a little bit more sense. If I go back to here, then I now want to look at 60 plus 17. Oh, and I hope we can stack those. So now look at this representation here on the number line. Oops, let me go back here. This idea of compensating, right? If we took away from this top add end and we gave it to the bottom add end, again, for me, when I write it horizontally, it helps me to see this decomposition. 63 plus 14, and so I'm going to write it this way in case it helps you too. 60 plus 3 plus 14. And now we can associate, right, the 3 with the 14 and get 60 plus 17, right? We can see this same 60 plus 17 here and here. And so what I want you to see now is when we kind of subtracted that 3, right? We went backwards on the number line, but then we went, we added this distance, right? Instead of being 14 long, now it's 17 long. So we still end at that same total, that same sum. And so that is way different than what we just did with Chrissy's strategy in compensating and subtraction, right? In subtraction, we're talking about the distance or the difference, and that stayed the same when we compensated, when we changed the minuend and the subtrahend. In addition, when we compensate, right, if we, or we, you know, decompose numbers and use the associative property to make friendly numbers, right? We associated those. Sorry, that yellow doesn't show up very nicely, right? We decomposed 63 into 60 plus 3 and added it to the 4 now to get this 60 plus 17, right? Friendlier numbers, easier addition. By taking away, right, changing that initial add end, it actually then increased this add end, right? The 14 went to 17. So we see that the total then stays the same when we use the number line representation. All right. So now let's check out Alex's strategy. Alex's strategy might be familiar to some. You can see, again, he's starting with the minuend, and then he's counting up or adding up, right? So that's another name for this strategy, counting up or adding up. And he does it in hops of friendly numbers. And so this is where we can see a number line is a great representation to show this. So we'll do this number 3 here that's not done. We'll start at 563, and I want to hop all the way to 712. And so I can do that by just making friendly numbers. Add 7 to get to 570, add 30 to get to 600, add 100, and you can see this isn't called an open number line, and you can see this is not proportional, right? 30 shouldn't be bigger than 100, but that's the beauty of the open number line, is that it can just show your hops and distances, and it doesn't have to be completely to scale or accurate. And now what he sees is that, check this out, right? This distance from 530 all the way to 712 is this sum, right? I'll use green. 7 plus 30 plus 100 plus 12. That's what he does here, right? He's recording it this way. So we can think about 563 plus 7 gives me 570, plus 30 gives me 600, plus 100 gives me 700, plus 12 gives me 712, right? That's how he went from 563 to 12, and now we can add up this right here, right? That's my distance or my difference. 130, 42 plus 7, so is 149. And go ahead, check it out. And so the last strategy we've been introduced to is Jamie's strategy. And we can see it kind of looks similar to our standard algorithm, but instead of crossing out numbers in the minuend, they're crossing out numbers in the subtrahend, right? And when we think about like 64 minus 29, we still start in the ones, like how Jamie's doing here. But if we're thinking about 4 minus 9, we don't cross out the 2. We would regroup. Oh, look, I caught myself. I know that the carrying and borrowing language is so insidious, right? We would regroup or trade from the 6 tens here and decrease, right? We would take one away. If you notice, what is Jamie doing? They're looking at the subtrahend and not decreasing that, but increasing. So, this is again, the standard algorithm here, starting with the ones and regrouping, the way that we've been taught. But this is very similar, but different, because they're using regrouping from the subtrahend. And so let's take a look at this example here, and we can work on it together. So we see, if you think about 2 ones and 6 ones, well, that'll give us a negative. So we would cross out the 3 in Jamie's method and make it a 4. And I loved how some people reflected, like, I could repeat the steps, right? That's the definition of algorithm. You can repeat the steps, but you don't understand what's happening. And that's what happens a lot for our kids with the standard algorithm, right? They can repeat the steps, but because they don't understand really what's happening, if they forget a step or make a mistake, they don't realize that they made a mistake, and they're not making sense of what they're doing. They're just trying to memorize these steps. And so I can see we can do that here, right? Okay, I see Jamie crosses out the 3, makes it a 4, and gives the 10 up here. So now I have 12 minus 6 is 6, 7 minus 4, 70 minus 40 is 3, and 6 minus 600 minus 300 is 300. And go ahead, check it in your calculator. Is that true? Or try it in the standard algorithm traditional way. Is that true? And now I want to show you next, how can we represent that? How do we make sense of that? So let's take a look at Jamie's strategy, and I'm now representing her number 2 on that example, 236 minus 127. And so I set it up with the base 10 blocks, 2 hundreds, 2 flats, 3 tens, and 6 ones, 1 flat, 2 rods, and 7 ones. And so now I want you to see, so Jamie's strategy looks like this, right? We think we need to regroup. We need more ones up here. So I'm gonna cross the 2 out, I make it a 3, and then I give the 10 up here, right? That's their strategy. So what is Jamie doing exactly? Well, let's think about it like this. I'm increasing a 10 to my subtrahend, and then I'm increasing a 10 to my minuend, right? It's now reminds us a lot of that compensation strategy. What I did to my subtrahend, I did to my minuend, right? Added a 10, but this isn't 10 in the tens place. It's now 10, ungroup those objects. Oh, there we go, right? It's now 10 single units in the ones place, or 16 in the ones right here, right? 16, boom.